Okay, 1975 AB6. R is going to be the region in the first quadrant bounded by the graphs of x squared over 9 plus y squared over 81 equals 1 and 3x plus y equals 9. Well, the first shape is going to be an ellipse having this kind of shape. It will have a y-intercept of 9 and an x-intercept of 3. And the second equation is going to be y is equal to negative 3x plus 9. And that winds up looking something like that. So we have points of intersection at 0, 9 and 3, 0. The first thing we want to do is find an equation for an integral representing the area of R. And that will be the integral from 0 to 3. We'll always do top minus bottom. So it will be, we'd have to solve the ellipse for y, and you can verify that that's y is equal to square root of 81 minus 9x squared. So the top function is square root of 81 minus 9x squared minus the quantity negative 3x plus 9. And you don't have to go any further. You don't have to simplify. It says set up but do not evaluate. They don't care about simplifications at that point. You've got all the pieces there. You need to have the integration symbol. You need to have your limits correct. You need to have the two functions correct with a minus sign in between, and you need to have the dx. If you have all of those pieces there, you have full credit for that part. Alright, that's for part A. For part B, we want to take that area and we want to revolve it around the x-axis. And in this particular case, we're going to end up with the washers. And a washer is basically a larger disk with a smaller disk punched out of it. And that gives us the pi capital R squared minus pi little r squared, where capital R is the radius of the outside circle and little r is the radius of the inside circle. So for this one, we're going to get that volume is equal to pi times the integral from 0 to 3 of square root of 81 minus 9x quantity squared, that's capital R squared, minus the quantity negative 3x plus 9 squared dx. Again, the simplification is not important here. You want to show that you have you have pi capital R squared minus pi little r squared there. And so you have the integral from 0 to 3, pi times the integral from 0 to 3 of square root of 81 minus 9x squared quantity squared minus the quantity negative 3x plus 9 squared. That's it for part B. And we'll scroll up a little for part C. Alright, for part C, we want to set up but not evaluate the integral representing the volume when we rotate that around the x-axis. Sorry, around the y-axis. So we take a representative strip and we're going to revolve that around the x-axis, y-axis, sorry. And so we get this cylindrical shell that has a surface area of 2 pi RH. And so the volume is 2 pi integral from 0 to 3. The radius is x again, and then h is going to be the difference of the two functions, and dx is the thickness of each cylindrical shell. And so that's it. That's all that needs to be done on that particular one, is to set it up. You don't need to integrate it. And so we're done. Sometimes you'll be asked to set up and not evaluate it, since that is very difficult to actually carry out the integration on. If it's a calculator question, which these often are, you can set them up and then you can evaluate them on your calculator as well. We'll go on to the next problem.